Righto, well, one and all, beautiful a day for a webinar. How about we get things rolling? Thank you to everyone who's dialed in today. Another uber popular webinar. Welcome, Daniel. Daniel's giving me a hand today, so it's much appreciated because we've got a lot of people coming today. So 750 registrations at the last count. Can you believe that? But before we dive into the topic today, just a couple of very quick things about some stuff that I think maybe a lot of you guys would be interested in. First up, you might have seen Daniel's been busy developing the WSUD compliance framework, the WSUD maintenance compliance framework. Something like 130 individuals from 70 organizations have contributed to it. And that's now live, open for public consultation. So if you're keen to find out more, obviously you can jump on the QR code there or just reach out to Daniel separately. On a related matter, there's a couple of obviously WSUD compliance related webinars and meetings coming up. The first up is probably that law and order webinar, which is fascinating. Long story short, we've paid some very expensive lawyers to look at whether it's illegal to not maintain stormwater treatment assets, etc. Spoiler alert, it is illegal and the fines are significant. So I'd highly encourage everyone in the industry, particularly if you're a government employee or regulator, I reckon you want to dial into that one because the implications to our industry are enormous. And obviously there's that WSUD Compliance Network meeting as well. Look, Ocean Protect do a bunch of educational stuff, and one of them is obviously webinars. There's another one that's super popular is our podcast. 160 plus episodes deep, super popular, bizarrely enough. If you're keen to listen to a podcast that talks about stormwater, I mean, who wouldn't? I think we're the only one on the interweb. So jump on, subscribe, give us a 5-star rating, etc., all that stuff. But yeah, some doozy episodes. And I think Daniel Ryder's making a guest appearance in our next episode as well. So look forward to that. Talking about the WSUD compliance framework.
Yep.
But let's dive into it. First up, and I'd just like to acknowledge the I'm dialing in from Brisbane, so I'd like to acknowledge the traditional custodians of the land where I'm presenting from, the Yagara and Turrbal people, and I pay my respects to their elders, past, present, and emerging. And look, it's worth noting this is the 5th webinar in our Stormwater Fundamentals series. They've been super popular. Like I said, 750 registrations already at this one today, which is bizarre. In case you miss it, the slides and the recordings are always available on our website. So jump on that if you miss it, and it generally takes about a day or two to get up. And obviously we're promoting them via our newsletter. So if you're not already subscribing to our Ocean Protect newsletter, to find out about the upcoming webinars, including these and others, I'd suggest jumping on the website and subscribing if you're not already. But look, and just a quick reminder about a few housekeeping things. If you haven't already, please complete the poll survey. There's a couple of questions that are particularly relevant for today's topic, which I'm going to talk at. So if you haven't already, please fill out that poll survey. If you do have any questions, it makes it a lot easier for us to answer those questions if you put the questions in the Q&A panel. And as I mentioned before, the slides and the recording will be made available at the oceanprotect.com.au website. And whilst I'm presenting, if you want to if there's any technical dramas or whatever, feel free to, probably best to reach out to Daniel in the chat. So probably the best port of call, Daniel. You'll help.
I'll just sit.
Anyone's dramas.
I'll sit in the back, just kind of letting people.
Cool. Oh, I realize I'm not wearing a headset, so I can't hear you. So.
Okay.
Sorry.
No, that's all good. Yep. I'll sit in the background.
And look, in terms of CPD forms, we get a lot of requests for these, so apologies in advance if we're taking a little bit of time. There's a bit of backlog. So, but if you do have any CPD requests, please please email them to inquiries@oceanprotect.com.au. Cool. Well, let's get this show on the road. So this is what we're going to talk about today. What is water sensitive urban design? Why is it important? Talk about the targets. And also I'm going to show you a whole bunch of examples of asset types that we have used to integrate, have integrated into various sites to help achieve water sensitive urban design. So, but first up, what is water sensitive urban design? I guess I love coming back to fundamentals. So this is obviously a conceptual diagram of a natural catchment, a lot of trees, a lot of vegetation. In a natural water balance, we obviously get rainfall and we get a lot of evapotranspiration. We get a lot of water soaking into the ground and contributing to base flow or groundwater recharge. We don't get that much in the way of surface runoff. We need a lot of rainfall to fall. Generally, it's at least about 25 mils in a day to generate any runoff. But obviously, when we develop an area, when we put a whole bunch of roads, houses, etc., knock down a whole bunch of vegetation often, we very much change the water balance. In terms of stormwater, but also equally, we obviously require potable water to come into our urban areas. And obviously we generate a lot of sewage as well. So the water balance fundamentally changes. So fundamentally, when we're talking about water sensitive urban design, we really want to make this function more like this. And how do we do that? And that's essentially what water sensitive urban design is trying to do, to try to get our urban environments to have a more closer resemblance from a water perspective to our natural pre-development conditions. So that means a whole bunch of stormwater management, stormwater treatment, stormwater reuse, trying to promote infiltration or soaking into the ground, and ideally reducing our wastewater discharges and reducing our potable water consumptions. There's a whole bunch of things we use water for, potable water for, that we kind of could use other sources for example, toilet flushing, irrigation, etc. And it's worthwhile noting that water-sensitive urban design isn't just about stormwater. There's a strong focus on stormwater, obviously, and I'll talk about most of that, a lot of that today. But it's worthwhile noting it's just one element of the water cycle. So when it comes to water-sensitive urban design, we're really trying to achieve total water cycle management. So really minimizing potable discharges and potable water consumption and wastewater discharges as well. Apologies in advance if you hear a couple of dogs in the background. I've got 4 at my feet as we speak. And it's also worth noting that water sensitive urban design is just part of one part of ecological sustainability development. But what is it in terms of its definition? And this is straight out of Engineers Australia. Water sensitive urban design, often the acronym of WSUD, WSUD is used, is an approach to urban planning and design that integrates land and water planning and management into urban design. So basically, it's an approach, it's a philosophy. It's not an individual asset or series of assets. Okay, it's a way, it's an approach. So why is it important? Well, if I just look at where I'm calling from today, so in Southeast Queensland, apologies, I'm going to turn some dogs off. Hang on. Apologies in advance for the loud dogs. So in Queensland, in Southeast Queensland, we've gone through some major challenges, particularly in relation to climate change. So Wivenhoe Dam just recently was down to critically low levels. We almost needed to truck water into our urban environments. And then shortly after, we went through a period of significant flooding and then more flooding. And obviously climate change is playing a role there. We are basically seeing our climate change. So more extreme weather conditions, more flooding, more extremely hot conditions, etc. Also, we're seeing an increase in the number of extremely hot days. This is straight out of the Bureau of Meteorology and CSIRO State of the Climate Report. Long story short, we are seeing an increasing frequency of the number of hot days. So what does that mean? That means more pressure on our health services. Sure, it makes it easy to get out of bed on a cold winter's morning, but also means a greater amount of people suffering from heat-related illnesses, which causes all sorts of dramas. Equally, we're seeing the biggest heat impacts in our urban environments, particularly related to the urban heat island effect, which is basically our urban environments are essentially hotter than our natural environments because of that increased imperviousness, etc. And obviously that only exacerbates increased frequency of heat-related illnesses as well. And that's a massive issue. In some of our most highly populated areas, the fastest growing areas in Australia, is probably some of the most heavily impacted by the urban heat island effect and climate change. And particularly in relation to, like, for example, Western Sydney, which is potentially Australia's fastest growing area, there's predictions that it might be unlivable to live there. So some of our most fastest growing areas with the most highest rates of population growth may actually be too hot for people to live in, which is a scary predicament to think about. So a lot of challenges, but equally, people still keep coming to Australia. I mean, why not? So population growth is still high. Obviously, we saw a downturn in COVID, but it's people still coming to Australia. Population rates are remaining fairly steady. Particularly where I am in Southeast Queensland. So this is straight out of the SEQ regional plan. A lot more people are coming to Southeast Queensland. So what's that? Another 2.2 million people requiring 900,000 homes in 23 years. That's amazing. Equally in New South Wales, increased population growth. And in Southeast Queensland, as an example, we have a pretty snazzy ecosystem health monitoring program. So the Healthy Waterways guys, or I think it's called Healthy Land and Water, have been collecting ecosystem health data on a bunch of our waterways and determining their condition. And this has been going on for a very, very long time. And fundamentally, we are seeing a decline in the health of our waterways. And you might think, so what? Who cares? Does it really matter? Well, let me talk about that. So if you don't care about dolphins, dugongs, and platypus, if you just cared about the mighty dollar, this is a comparison of Moreton Bay, which is the main waterway receiving environment in Southeast Queensland, and compared against Sydney Harbour in terms of a whole bunch of economic indicators. Now, interestingly, from my perspective, Moreton Bay is basically generating similar revenue to Sydney Harbour, potentially the most iconic waterway in Australia, or in the world, sorry. But Sydney Harbour, for example, has zero value for primary industries, i.e. commercial fishing. Why is that the case? It's because it's too polluted in Sydney Harbour to do any commercial fishing. And you can imagine the potential economic impacts associated with the deterioration of the health of any of these waterways. So again, even if you only care about the dollars and cents, economic drivers for protecting our waterways are significant. And then obviously there's a whole bunch of social and cultural values. That's where we basically near or in or on our waterways is where a lot of people spend their spare time. Obviously, there's a whole bunch of ecological values for our waterways and essentially water quality or pollution or other stormwater related aspects impact the health of our waterways. So whether it's litter, whether it's nutrients contributing to excessive algal growth and eutrophication, or whether it's just plain old dirt discharging to our waterways and bay environments, these have real ecological, economic, and social and cultural impacts when we don't protect our waterways properly. And you might think, still don't care. Do you think the Australian public cares? This is one of the questions I asked you guys in the poll. Okay, do you guys care? Do you guys care about the health of our waterways? There's a lot of things to care about when it comes to increasing population growth, but how do things compare? And if I look at the poll, I'm just going to try and get the poll up myself. I'll leave the poll open because I can see something like 200 people have already answered these poll questions. So the first question I asked was, basically this question: with increasing population growth in Australia, what impacts are you most concerned about? And Daniel can see the results as I can. But interestingly, the top ones, okay, I'm looking at 61% of people have said less green space is the top one. Interestingly, housing density at 54% is second top. They're live results. Everyone's putting them through. Interestingly, marine and waterway health is 49%. So I'll leave those polls open just for everyone's benefit. So please keep on putting your answers in. But the reason I ask this question is because it's actually a survey that we commissioned, Ocean Protect commissioned a few years ago. We set the questions and we got an independent survey company to survey 1,000 people across Australia, all demographics, all age groups, independent survey, like I said, 1,000 people, and we asked them that question. So I'll show you the results because this for me was really interesting. So this is the results of what the survey recipients thought in terms of what impacts were they most concerned about. So I'm going to show you from lowest priority to highest. So lack of character in new housing was low, car parking number 2, marine and waterway health was number 1. I'm just going to say this again. So the number 1 concern of the Australian public, independent survey of 1,000 people across Australia, showed that the number one concern of the Australian public was marine and waterway health. Above traffic, above air quality, above house prices. Now, everything in the news that you see, breakfast television in the morning, every half hour, some guy's in a helicopter talking about traffic. It's only going to get worse. What do we hear in the media? Jobs, house prices, and deservingly so. These are key issues, but equally, marine and waterway health is what in this survey was the number one concern. Does that surprise anyone? Happy to hear your thoughts and feedback in the chat. Who thinks, hands up if you think we fudged the numbers. So you can put your hands up if you like in the webinar portal. So I can see a few hands are being raised. Ocean Protect, you would fudge the numbers. I've currently got, it's hit 10, 12, 13, 14, 15. 15 hands have been raised saying we've fudged the numbers. It's okay. That's fine. I did ask the question, but we actually copied the question from another survey. We copied the question from the survey by the state government of Queensland. They asked 3,500 people or thereabouts from Noosa to Gold Coast, Brisbane to Toowoomba, the same question. They actually gave people more options. And I want to show you what the results were. So again, from lowest concerns to highest concern. This is a survey done by 2010. It's publicly available. The number one concern of the Southeast Queensland public when it comes to population growth was also marine and waterway health. Now, the reason I talk about this is because I want to highlight the fact that it's a major concern of the Australian public. So if it's a concern, we really should be doing a good job of protecting our marine and waterway health from the perils of population growth. Have I blown anyone's mind yet? Like, everyone's just like, feel free to put in the chat if you still think I'm fudging the numbers or I've just blown your minds. Another survey, and this for me shows why, I guess, often when it comes to stormwater, I think it's really important to talk about litter. And this is a survey done by Health, Land and Water and QUT. The number one concern of the survey recipients was litter pollution. So it didn't matter whether you're a tree-hugging vegan, man bun wearing hippie like me, or a non-greenie. The number one concern of both non-greenies and greenies was litter pollution. So why? It's because it's anthropogenic. It's easy to understand. But fundamentally, when it comes to stormwater is the number one source of plastic pollution and litter in our waterways and ocean environments. So yeah, something to think about. And we see the values of our waterways reflected in various government-related documents. So this is straight out of the Health, Land and Water, talking about the fact that, people in the Southeast Queensland community really value the health of their waterways. It's important for recreational health, cultural, economic, etc. Values. So it's not surprising that we have a deep connection with nature and waterways, and it's an important part of our lives. Equally, a survey that I was involved with a little while ago in a catchment within Southeast Queensland, and it's probably considered a low socioeconomic area. I won't say where it is, but we asked them. This is a word cloud response. So bigger words show where bigger words basically indicate that more people were concerned about this issue. And again, what are you concerned about in this catchment? Waterway health was the number one concern over drainage, flooding, etc. Which is interesting because this was a catchment that experienced significant flooding problems. Again, what major changes or issues have you seen within this catchment? Decreased water quality in the health of their waterways was the main thing that they had seen in this catchment. And equally in Moreton Bay, for Moreton Bay Regional Council, they have a vision of being a water sensitive region. So water sensitive urban design is a key part of that vision. Equally in Brisbane, where I am, this is the Mayor Quirk talking about, water being our most precious resource. Our bay, river, and environmental waterways are important, et cetera, et cetera, et cetera. So basically, a whole bunch of government documents saying the same thing, saying waterways and the protection of our waterways is vitally important for the society and for a whole bunch of reasons. And how to do that? Well, straight out of the Health of Waterways guidebook is water sensitive urban design is the preferred approach for mitigating the impacts of urbanisation on the natural waterway cycle and to reconnect communities. So all these issues facing the health of our waterways when it comes to urban population growth, and the preferred approach is water sensitive urban design. Cool. Have I convinced anyone that it's important yet? I'm hoping I am. I'm hoping I have. Best practice targets. Let's talk about those and why they aren't really best practice targets. Okay, there's a whole bunch of regulatory drivers for the targets, the stormwater management targets. In Queensland, we've got state planning policy, environmental water policy, etc. Each state has their own sort of similar sort of legislative drivers. Sometimes they do vary from state to state and territory to territory. And in Queensland, which is similar to other parts of the Australia, we have targets around both construction phase stormwater management, so erosion sediment control, and you probably see something like this in whether you're in Victoria or Tasmania or South Australia, etc. But equally, we have post-construction or operational phase stormwater management objectives, and they generally look something like this. So you probably heard the term 80-60-45 or 85-65-45 or something like that, basically talking about these are targets to reduce the pollutant loads discharged from a particular site. So they look at average annual loads. So they do a music model or something similar and work out, okay, what do I need to reduce the amount of pollution being generated from my site relative to the development without any treatment devices. And I'll come back to why that's important in a sec. So yeah, you can see in Queensland, they might vary a little bit. In different states, they do vary as well, but something fairly similar to this. What are they based on? And it's a bizarre thing to talk about, but fundamentally, and there's a lot of discussion around this, they are basically based on how big, or what is practical to achieve on your site for a bioretention system. So the most stock standard approach to meeting stormwater management objectives, from my perspective at least, is putting in bioretention systems. And the targets are basically based on, okay, what's sort of a reasonably practical target to achieve if we're using bioretention systems. So you can see here in Brisbane, for example, this is total nitrogen reduction on the y-axis, and this is the bioretention area relative to the size of the catchment upstream. So basically after about, more or less 2% of the size of the upstream catchment, so a bioretention system with an area, 2% of the upstream catchment area, after about 2%, you don't really get that much benefit in terms of load reductions for nitrogen. And that's basically, you can see if you go across here, that value there, that line on the graph there is a 45% load reduction. And so that's our target. So in Brisbane, at least, the target for stormwater management is 45% nitrogen reduction, 60% for phosphorus, and 80% for solids. And this is basically what it's based on. How big of a bioretention system can you put into that's practical, and you don't get that much benefit if you make it much bigger. Okay. So, and this again, straight out of the Healthy Waterways Guidebook, which is our sort of main capacity building organisation in Southeast Queensland when it comes to water sensitive design. They've changed their names a few times since this document was produced. But yeah, the targets are based on, so the targets, the 80-60-45 targets or something similar, are based on how well bioretention systems can improve the quality of urban stormwater runoff without the treatment systems being excessively large. The targets, do not necessarily achieve a no worsening of pollutant loads compared to previous or pre-development catchment conditions. So again, the targets are based on what's practical if you use bioretention systems. And just to prove a point, these are the results of some music models I've done for a conceptual site in Brisbane, 1 hectare development, forested. So there's a forested land use scenario, urban residential scenario without any treatment, and then you've got a site, urban development, the same urban development, just with an 80% reduction in those TSS loads. So you can see the forest has a little bit lower TSS, average annual load, relative to the other two scenarios, but equally, same thing for phosphorus, and if anything worse. So even if you do SPP compliance, that's 60% reduction in phosphorus, you are still seeing a significant increase in phosphorus loads. Same thing for nitrogen. And then we look at flow. So in Southeast Queensland, we don't have flow reduction targets. We basically, we see obviously a significant increase in average annual flow volumes relative to the forested scenario. We know with increased frequency and volume of flow, we see ecological impacts. And this is something we talked about in the last fundamental session. Cool. It's worth noting that in some parts of Australia, there's flow reduction targets. So in Victoria, they've recently introduced flow volume reduction targets, and similarly on some developments in Western Sydney, they do have flow reduction targets as well. But it's, for my mind, there are some key questions to ask around the appropriateness of these targets. And I'd really query their appropriateness, basically. So key questions from my perspective is, what is the scientific basis for these targets? Now, we all know that increased flow, volume and frequency does impact on ecological health, et cetera. But I really doubt the applicability or the appropriateness of an annual volumetric flow reduction target. Are the modeling methods appropriate? We're using music typically. Is that an appropriate method to use, recognizing there's often very little calibration being undertaken, and we're using historical climate data, et cetera? Are the assumed water losses realistic or sustainable? Like we're often requiring water losses, whether it's exfiltration, harvesting. I've seen misting sprays being proposed to just basically lose water. Is that sustainable? Is that going to be essentially achieved long term? Exfiltration rates, for example, going to be achieved, recognizing that there might be some blockages long term. Other targets are practical at all. And also recognizing that often they say you just can't have as much imperviousness in your particular area. Does that mean urban sprawl is going to be exacerbated? I won't go into any more further detail about this. There's a whole bunch of further information on the Ocean Protect website. You can see there where we've actually provided feedback to Vic EPA and other Sydney Water around the appropriateness of these targets. So if you're keen to check out that further, just jump on that website there. But fundamentally, are these best practice targets? From my perspective, they are very generic. They're typically based solely on what music predicts bioretention can achieve. And again, that's based on historical climate data, potentially outdated or at least incorrect pollutant export properties. So we're assuming urban, residential, and commercial, industrial, the export properties that are assumed in music guidelines, et cetera, are actually appropriate. And there's a lot of science to indicate that they are not. And also, from the biggest one from my perspective is that we use music and we use the algorithms in music for the bioretention node, which are based solely on laboratory scale studies. So a few years ago, 15 plus years ago, some scientists looked at microcosms in a lab environment, typically in Melbourne, but some were done in Loganholme. And they worked out, they basically dosed these bioretention systems in a lab environment with some synthetic stormwater. And that is what basically is used for music modeling of bioretention systems. And that, for me, is not appropriate. We definitely need real-world monitoring to demonstrate the efficacy of bioretention systems. And I really think these targets are a key reason why we do see oversimplified and generalized outcomes, i.e. bioretention is just the gold standard for some reason. And we often see very high rates of operational problems with these bioretention systems. Often there's very little appreciation for the downstream waterway values. Are TNTP targets appropriate for these downstream waterways? Are there other pollutants of concern we should be concerned about? Another one is the fact that the flow and load reduction targets provide no incentive to reduce the generation of flow and pollution. So it's often better or easier to achieve your target if your site is dirty. So it's obviously easier to clean dirty water than it is to clean water that's actually reasonably clean already. So again, that's a failing of the target, at least in their current form. But for my mind, the key thing is, whilst these targets are really essential, and they are essential, we need to do something to help protect our downstream waterways. It's just one part of what is often coined total water cycle management. So, for example, I worked on a total water cycle management plan for Moreton Bay Council a few years ago, and best practice targets on urban development areas was just one part. You had to essentially ensure that the waterway health did not deteriorate. So you needed to do rural best management practices, stormwater harvesting, first and second order waterway protection, et cetera, et cetera, et cetera. Wastewater reuse, just to achieve, like, basically every tool in the catchment manager's toolkit had to be used to ensure that the waterways in Moreton Bay Regional Council did not deteriorate. So again, best practice targets for urban development are just one part of that. Cool. And it's also worth noting that it's a multidisciplinary endeavor. It's not just some engineer with a music model, working out how big your bio needs to be. It should be a multidisciplinary endeavor with a whole bunch of stakeholders, including eventual asset owners or managers. Cool. So I'm going to show you a whole bunch of examples of stormwater treatment assets that are often integrated to achieve water-sensitive urban design. Probably it's a sad reflection of how I spend my spare time taking photos of water-sensitive urban design assets. But I'm just going to show you a whole bunch of examples. I'm not going to talk about the potential operational problems, etc. I'll save that for another day because I'm just conscious of everyone's time. But in terms of examples, these are probably the more standard examples we see on most developments for urban environments. And I'm just going to run through a whole bunch of examples now with the time that I have available. So pre-treatment first up. So when I talk about pre-treatment, I'm talking about removing litter, plastic pollution, solids as best I can prior to discharging downstream, whether it's into a waterway or often a downstream treatment device. And if you can see from the photos here, like these are gully pit baskets integrated into roadside gully pits, and they capture a whole bunch of very nasty pollution that you do not want in any downstream bioretention systems or wetlands. And this is an end-of-line gross pollutant trap. So it's a lot easier to clean out these assets than it is to try and remove this pollution out of a vegetated wetland, for example. This stuff will just smother plants, everything, basically. And it's a lot easier to just come in with a sucker truck and rip this stuff out out of a GPT than it is to try and manually remove it from a wetland or bioretention system. Swales and buffer strips. So these are pretty simple. They basically just offer an alternative to curbs and guttering or concrete channels, etc. And they work very simply. Just basically trying to slow down water, promote infiltration, promote enhanced sedimentation with the vegetation, etc. Bit of biological uptake of the pollution. And these are just buffer strips in this is Springfield Lakes in southeast Queensland. So instead of the water hitting the curb and going into a pit and a pipe, it just basically flows off into the vegetated area. Pretty simple. This goes into swale. This is Sunnybank in Queensland. So again, water just sheet flows off the road into a vegetated channel. This is that Coomera water. So you can see these devices do need a fair bit of space. You often need very specific site conditions. So swales are pretty much only good for sites with gradients between 1% to 4%. If it's too flat, you'll have ponding. If it's too steep, you'll have erosion and scour. So they're not commonly integrated, but the concept is great, slowing down water, providing that enhanced sedimentation, filtration, and they can be big systems as well. This is a very old swale in Currabee in Queensland. So water comes into a big area. It's treated with a GPT upstream and then comes into this area, flows through here and goes into the outflow pit. Pretty simple. Sedimentation basins. These are all about basically just slowing water down, promoting sedimentation, etc. And look, this is an example of one in Coorparoo in Brisbane, Bowie Flat wetland or Bridgewater Creek wetland if you're a local. So this is obviously that's a sedimentation basin there, and this is the macrophyte zone. So this is basically providing pre-treatment prior to discharging into the macrophyte zone. So small frequent flows will go into the macrophyte zone via this little pit here into the macrophyte zone. High flows will bypass. So often sed basins are used for a bit of hydraulic control as well. So you've got a trash rack upstream of the said basin at Coorparoo, which does something, probably not a great device, but it at least provides some litter removal, I guess. Then it goes into the said basin. The low flows will discharge in the macrophyte zone by this outlet structure. You can drive in with an excavator to clean it out, which won't happen. And trying to clean out a driving excavator into a said basin is not a very good idea at all, but that's another story. But another example is one. This is a Brisbane City Council retrofit project. This is the before photo, and this is the after photo. Before, after. So you can basically see what this device does. It's obviously an improvement. Provides habitat, slowing down on water, looks good, but it also stops a whole bunch of sediment from discharging downstream. This is another example of a sed basin. This one's upstream of a bioretention system at the Woodlands Estate in Waterford. Another wetland out at North Lakes, I believe. Sorry, now we'll talk about wetlands. Sorry. Often wetlands have sed basins like this one. This is the Glen May wetland in Morayfield in southeast Queensland. But the downstream of the said basin here is this macrophyte zone, and this is planted out, obviously. So typically wetlands are shallow, densely vegetated systems, promoting, again, sedimentation, enhanced filtration, slowing down water, evapotranspiration, obviously potentially providing habitat and ecological values, etc. One thing to keep in mind is that you obviously do need to pre-treat the water. So you will attract wildlife to these environments. And I think there's a growing awareness that we've got to be very careful about creating ecological traps for wildlife that might come into here, with a particular concern around PFAS. There's been some studies recently showing that if you some of these wetlands can accumulate pollution, and some of that pollutants can be very nasty to the ecology that is attracted to these wetland environments. So just something to keep in mind. But yeah, lots of photos of densely vegetated wetland environments. This is a really interesting example. This is the Bowie's Flat wetland, or Cooperoo wetland, which I showed before. That was a council retrofit project. So this is the before photo. It was a concrete drain through a park, a whole bunch of safety issues around kids trying to get from one side of the park to the other. This is the before photo, and this is the after photo. So before, after. So again, water sensitive urban design, trying to promote, stormwater treatment, water quality improvement, also providing a bunch of other benefits in terms of amenity, connection to waterways, public safety, etc. Urban cooling, you name it. Bioretention systems, or rain gardens. So this is potentially, I think it's the second oldest bioretention system in Australia. This is at Bracken Ridge in Hoyland Street in southeast Queensland. This is built in 2001. I went there just recently. It looks pretty good to me. You drive past it and probably wouldn't know it was there. Bioretention system at Springfield Lakes at the promenade. Another one at Springfield Lakes. This is the creekside. So again, just densely vegetated water comes in, you soak through the soil. One at Red Bank Plains. Looks good. Gold Coast City Council retrofitted this into an existing park, similar to the other retrofit projects I showed before, but this is the bioretention system. Again, just looks like a garden bed. This is another one at 17 Mile Rocks in Brisbane. So that centre median is a bioretention system. Willawong Bus Depot, that's a bioretention system. So ideally just landscape features that water just drains into and slows the water down, enhanced sedimentation, filtration, etc. Similar water sensitive urban design principles to the other devices. Bray Park in Queensland. And then you've got a whole bunch of streetscape examples. So at Docklands, for example, there's lots of these trees, and they all are bioretention systems, I believe, to the best of my knowledge anyway. So these trees you can see on the left, they're bioretention systems. So the little cutout in the curb lets water in. If the water gets too high, just surcharge into the downstream pit. But yeah, looks great. Why not have these self-watering trees? Canberra, and a whole bunch of streetscape systems around the Sunshine Coast. They are everywhere because it's generally a fairly flat environment. So it's often those conditions lend itself to more at-source bioretention systems. Noosa, etc. This is a little bit different. These are the Filterra bioretention systems. So these are just like conventional bioretention, but are smaller, typically about 3 to 5 times smaller. So this is a Filterra bioretention system at Warwick Farm. That's about 5 years old, I think, by memory. This is another one we've been monitoring. I saw full disclosure, Ocean Protect do provide Filterra bioretention systems, so conflict of interest. But yeah, this is a Filterra bioretention system that we've been monitoring for about 6 years now. Its performance data that's got published peer-reviewed journals associated with it, etc. This is some of our systems out at Silverdale. There's 2 big Filterra bioretention systems out at Silverdale. So again, just looks like a conventional bioretention system. These would have been 5 times bigger if it had been a conventional bioretention system. Basically, they're high flow bioretention systems, so water can drain through quicker. So hence they can be smaller. But visually, they look just like conventional bio. Another Filterra bio just recently planted out at Ingleburn. One at Bells Creek on the Sunshine Coast, etc. Lots of examples. And then you've got proprietary assets. Conflict of interest declaration, Ocean Protect. We do sell proprietary devices. These are storm filter cartridges. And these are, again, commonly featured in urban development. So I think off the top of my head, we've got Ocean Protect have about 66,000 different proprietary assets in the ground. I think storm filters, we've got about 30,000 plus. and they capture a whole bunch of really nasty pollution you don't want in the downstream waterway environments. So these are the storm filter cartridges I showed before. This is on the left-hand side. That's a close-up of the PSOR media, and that's on the left is before it was installed. On the right, it's after it was installed, so ready for a maintenance intervention. So we just suck out that media and replace it with new media, and just use all the other components for the next cartridges as well. But yeah, long story short, it captures a lot of pollution, a lot of really nasty, manky pollution. But again, a key fundamental aspect of water sensitive urban design is stopping this pollution, preventing this pollution, the high pollutant loads that don't appear in a natural environment, but also there's a whole bunch of pollutants that we see in devices that just do not appear in a natural environment, and you do not want this pollution in the downstream waterways. And I'd certainly challenge anyone who thinks that a wetland or bioretention system is good for stopping a lot of this stuff, because it'll just often kill the bioretention system. So give you an example, this is jellyfish installed, just before being installed at a site. So that's a before photo. And this is kind of shows you what they actually stop. So this is really, really manky pollution that you do not want in a downstream environment. These jellyfish are a membrane cartridge system, so very, very high surface area. So they're like an accordion. If you spread them out, they go for ages. But even with that high surface area, they capture a lot of really nasty pollution. And so these cartridges just need to be replaced roughly every 2 or 3 years, off the top of my head, depending on the site. Sometimes they're a lot worse than others. So that's it. That's a crash course in water sensitive design. I'm actually on time. Thank you so much for everyone's time. I'm gonna dive into questions now. So if you do have any questions, please put them in the Q&A, recognizing that this is just so that's basically water sensitive urban design session kind of ticked, excluding the Q&A. But if you do have any questions, I'm going to dive into them now. So again, just a reminder, folks, if you do have any questions, please put them in the Q&A panel. We always get asked the question, can I get the recording or the slides? They will always be made available at the oceanprotect.com.au/webinars page. So give us probably a couple of days. And if you do have a CPD request, please email us at that email address there. Cool. And obviously, if you've got questions that we don't get to today, you're welcome to just email me directly. But I can see, Daniel, the Q&A hotline is running hot.
Lots of questions coming through.
So I'll let you manage this. Give my voice a rest.
Yeah, no worries. I'll ask the questions. You can answer them. So Ross Woodward has asked, Clarence Valley Council stopped doing Healthy Rivers report some years ago. Why would they do that? How can community get that back on the agenda? Can your group, Ocean Protect, lend support to lobby for funding for this important data?
Great question, Ross. Yeah, why did they stop doing that? And it's interestingly, if I give you some insight, the EHMP report card changed in Southeast Queensland as well. It used to be purely about ecosystem health, and long story short, because of the report gradings were getting worse and worse, and a lot of councils were getting Fs and Es, they stopped. They basically changed the report card grading. From my perspective, at least, and I could be completely wrong, I'd love to talk about it, but they basically stopped doing the report card grading system purely based on ecosystem health because the results weren't good. And I suspect Clarence Valley Council might have actually made that decision themselves to stop doing that Healthy Rivers report, because it was bad news, and a lot of political leaders don't want to be held accountable to the decline of our waterways. And we will see a decline in our waterways if we don't appropriately protect them via, like I said, total water cycle management and a best practice target approach to urban stormwater management. So that's just a guess. I'm just guessing. But can your group lend support to lobby for funding? Look, we could try. I think the key thing from my perspective is highlighting the fact that marine and waterway health is a key area of concern for communities across Australia. And I'm sure it's similar for Clarence Valley Council. But if you'd like me to see if I can help directly, best to email me via the email address at that one. Does that answer the question okay, Daniel?
Yeah, no, that answered the question. On to the next question. So from Dave Janzo, who's from South Australia, who determined that WSUD is best approach to managing impacts of urbanization on water cycle.
Oh, someone smarter than me, Dave. Great question, though. It's a concept that's been given various different forms and various different titles over the last few decades. It was called. I remember Murray Powell telling me about this recently. It used to be called BMPs, and then it was SQUIDs, and then it was water sensitive urban design. But I think fundamentally, it's been a concept that's been around for a long time. I think originally coined in WA back in the days, picked up by Engineers Australia and a whole bunch of organisations around Australia. And I think fundamentally, it's fairly well recognised that to minimise the impacts of urban development, we need a water sensitive approach. Now, in terms of what that actually means, it can be interpreted a whole bunch of different ways. From my perspective, it needs to be considered far more holistically, recognizing that the targets we have are bare minimum. We just can't do offsets and expect our waterways to be healthy, and it needs to be part of total water cycle management. So overarching, the key approach is total water cycle management, recognizing that there's potable and sewage elements to this protecting our waterways, but water sensitive urban design and its focus on stormwater is just one approach. I hope that answers your question. I could talk about that all day, but I know there's a whole bunch of questions coming through. Apologies.
Next question, quite a long one from Sean Quilty.
Sean Quilty's never short of a long statement, is he? Hey, well, greetings, Sean. Legend.
So WSUD guidelines were fantastic when published 20 years ago and based on research testing prior to them. Nowadays, we have so much more literature, research evidence, and proprietary products that are much more efficient and even remove emerging pollutants. How do we implement innovative new solutions when policies force engineers to adopt inferior solutions? Anyone have experiences, case studies where councils have adopted in lieu of standard pollution reduction targets?
Oh, great question. So there's probably two parts to that question. First up, how do we implement innovative/new solutions when policies force engineers to adopt inferior solutions? I was literally in a meeting yesterday, and I won't mention the council name, but they basically said you have to do bioretention systems on this project. And the consultant emailed council with photos from 10 bioretention systems in the same development area. It was an industrial development area, and basically showed that in the first 12 months, all of the bioretention systems had failed. And that was enough to convince the council to consider something new and different. And in that case, it was the Jellyfish proprietary stormwater treatment assets. Yeah, I think evidence and science is the best way to do it. Basically, and not just looking at Australian science. There's a lot of things we can learn from the US in particular. They've been doing water sensitive design and stormwater treatment just as much as we have, if not more. And they, from my perspective, are a lot more amenable to actually looking at the science and looking at new and innovative solutions. So I'd say look at the science, particularly the Urban BMP database. I can see a link on that. Long story short, it shows that a whole bunch of different devices work better than our standard approach. But also with that, science means performance monitoring data in the real world. Now at Ocean Protect, we've got data coming out of our ears around how our devices are really good at removing pollution and protecting our waterways. And I really think councils should be looking at that real world science in particular. And in terms of case studies where council have adopted in lieu of standard pollution reduction targets, yeah, it's a great question. Obviously, some councils will just take offset money and run, which I think is a real big mistake, particularly for sites where you can reasonably practically put in stormwater treatment assets. If anything, I've seen councils and, for example, the Aura development, which is a massive development on the Sunshine Coast, has required above and beyond targets. So not just 80, 60, 45, but achieving no worsening to protect, in that case, to protect the high HEV values of the Bells Creek and Pumice Passage. So from my perspective, the targets are often bare minimum, not just best practice.
On to the next question. There's a few kind of on the similar sort of topic for this, but looking at how do you dispose of the pollutants from the proprietary assets, what is done with kind of the media and the jellyfish cartridges after being used, and yeah, what happens to those cartridges after they've been removed? Can they be recycled or done something else with?
Yeah, so when it comes to the storm filter, so we got two types of Ocean Protective got two types of cartridge systems. So the storm filter, basically the media is removed, and all other components of the storm filter are essentially reused. So it's like a gas bottle, swap and go. We remove the cartridge, take it back to our facility, replace the media. The media is depending on the location. In New South Wales, it is taken to a recycling facility where it is repurposed. In Victoria and Queensland and South Australia and Tasmania, the pollution is put to landfill. It's worth noting that it's often pretty manky pollutants, and you don't want it to put on your garden bed, for example. Cartridges for the jellyfish are generally put to landfill, but we are working on a few innovations to, I guess, to create a more sort of, I guess, circular economy in that space.
Next question. I'm going to pronounce her name wrong, but Nosheen Obaid.
Mhm.
So why are the Filterra bioretention much smaller than the typical bios? How are they achieving the same treatment outcomes? Have you got a similar chart to show what percentage of Filterra asset would be of total catchment to achieve the 45% reduction?
Yeah, I pretty much get to ask this every day. So great, thanks question, Norshin. So how is Filterra bioretention so much smaller than typical bioretention systems? So we use a different filter media. So conventional bioretention systems, the key difference between Filterra and conventional is conventional uses a sandy loam media. Filterra uses Filterra filter media. So the sandy loam media drains at roughly 200 millimeters an hour, thereabouts. The Filterra media drains much quicker. It's generally about 3.5 to 4.5, 5 meters an hour. So much quicker. So because water can get through the media or into the system much quicker, the systems can be much smaller. But equally, even though it does treat the water at a much higher rate, the pollutant concentration reductions are still really, really high. And that's been demonstrated by about 7 now independently published and peer-reviewed journal papers. So the secret sauce is the filter media, number one. So it's particularly developed to enhance plant growth and be a suitable environment for plants to grow in, but also treat water to really, really high standard. But also we do use a mulch layer on the surface of Filterra, which does a lot of the heavy lifting in terms of removing the solids and other pollutants that can otherwise block filter media. And that's whether it's sandy loam or Filterra. We do recommend replacing the mulch every year. And I think that's something that I'd consider doing for all conventional bioretention systems as well, the use of the mulch. In terms of this, have you got a similar chart to show what percentage of Filterra asset you need to achieve the 45% reduction? Not a chart, but generally there's a couple of different calculations, but one of them is obviously using music. But long story short, Filterra is typically sized at 0.3% of the upstream catchment. So the filter area is typically 0.3% of the upstream catchment area. Typically, conventional bio is probably 1 to 1.5%. Yeah, but 0.3% we generally see is the minimum we'd want to go for, but also is sufficient to achieve the 45% TN reduction and 80% TSS or 85%, whatever it might be in your local area.
Next question is kind of talking about who certifies and is there any guidance around proprietary systems in Australia?
Yeah, it's a question from Don Dilipa Disanyak. Sorry, Don, I'm not going to pronounce your surname. Yeah, it really varies across Australia. So who certifies proprietary assets across Australia? So it's basically individual councils and regulators. So each council often has their own rules and requirements, which makes it quite time consuming to get certified. But long story short, the vast majority of councils across Australia accept proprietary assets from Ocean Protect. And that's generally based on real world performance monitoring data, peer reviewed studies, published journal papers, etc. More recently, in the last few years, people might be familiar with SQUIDEP, the Stormwater Quality Improvement Device Evaluation Protocol. We love a good acronym in the stormwater industry, and that's led by Stormwater Australia. And so Stormwater Australia have this SQUIDEP process, which does provide certification for proprietary assets. And off the top of my head, Ocean Protective got a SQUIDEP verification for Ocean Guard, Stormfilter, Peace Orb, and Jellyfish as well. And hopefully more to come.
Next question is from Alex B. Estado. So fairly new with Australian standards. Where can I find the design standards for WSUD bioretention systems, or is it different in various states and all councils?
Yeah, great question, Alex B. number one, you can always email me. I've got a library that I can just ditch with you or send you. But yeah, it does vary from jurisdiction to jurisdiction. But having said that, they are very similar across Australia. So I'd probably suggest Water by Design or Blacktown City Council would be great sources. So Blacktown City Council in particular is probably a leader around design standards for water sensitive design and bioretention systems. So they've got resources online, but certainly so do other councils across Australia as well. But they're probably the two ones I'd probably recommend as a starting point.
That's good. Next question from TJ Mund. How would you improve the music modeling for now?
Yeah, look, I think there needs to be a proper review of, in particular, the performance of bioretention systems. The fact that we're still using lab-based data to predict the performance of bioretention systems in the real world is just laughable. It's very widely recognised that a lab assessment is not enough to demonstrate the performance of stormwater treatment assets in the real world. So I'd suggest doing a review and update of the music algorithms for bioretention systems in particular as a starting point. Equally, you could look at, we've got a whole bunch more data around pollutant export characteristics for different land use types, urban, residential, industrial, commercial. And I think it'd be appropriate to look at those being updated as well with the new science that we have available.
Good. Next question from Zach. I have no idea how to say that.
DeRay. I know this because there's a Western Bulldogs player who, Taylor DeRay, who's just played 200th game on the weekend. So I know how to. So Zach DeRay.
Zach DeRay.
You go. Sorry.
What are the differences between a traditional bioretention system and a Filterra one?
Great question. So I sort of touched this briefly before, but the key difference is the filter media. So instead of traditional bios use sandy loam media, Filterra, we use Filterra. A couple other key differences is we use a mulch layer on the surface. We're far more pedantic in making sure that filter media is appropriate, not just, there's some very wishy-washy QA/QC procedures I see for other conventional bioretention media. But also we do a few things to maximize the resilience of Filterra, particularly around flow distribution, keeping them offline. So not just accepting high flows in particular, a bunch of things. I think for me, the key one is also we do the design, installation, and then look after it for a year. So if something goes wrong, Ocean Protect will fix it up. Whereas conventional bio, I see so many cooks in the kitchen, and if something goes wrong, it's hard to work out what happened, why did it go wrong. Thanks, Zach.
Back to Alex B. Estado, he was asking about whether we can go back to the slides with
this
the CPD.
One.
Yep.
Yeah.
So
yeah.
Inquiries,
so again, you go.
Inquiries at oceanprotect.com.au is where you can email to get the CPD forms. Daniel Kang, what happened? So again, this is talking about contaminants in the cartridges. The Vloxley, are floating wetlands a solution that Ocean Protect are looking into or provide proprietary rafts?
No, not currently. We've got a range of innovations that we already have available. We are bringing out some new ones, and we'll probably announce that in the next few months. So watch this space.
So that's done. So Lucy Peljo, can you please provide the results of the testing done on the sediment collected within the jellyfish systems?
Oh, Lucy's one of my former colleagues. So greetings, Lucy. I worked with Lucy for about 10 years. So she's always asking hard questions. So thank you, Lucy. That's okay. No, look, we can. We're actually, and Daniel would know this firsthand, we're actually working with a few different groups, and including the University of New South Wales, analysing the contents of some of our various devices, particularly around the microplastic contamination, etc. And I can share those results with you, Lucy. So maybe email me after today, and I can share that with you directly. But long story short, we see a lot of microplastics in these devices, a whole bunch of contaminants. So it's not just sediment, and it's stuff that you certainly don't want in your waterways.
Next question, Mahad Kamal. Have you come across used True Grid pavers? Would you be able to provide comment on the product as we're thinking of using it in one of our projects?
I have seen them sponsor a few Stormwater Queensland events. I haven't necessarily used them for any of our projects. I do have concerns around permeable pavement or permeable pavers, if that's what True Grid are offering. The key one is just blockage. We do see with anything that's a physical barrier or filter, it will block over time. And my concern around porous pavers or permeable pavement is how do they manage that risk of blockage? So I couldn't comment specifically about True Grid, but that
Mm.
probably would be my main concern around the sustainability or functionality of these assets.
Marissa Pasella, does the WSUD fit under the idea of integrated water management system, and how do you see it
Mm.
feasible to be implemented in old urban areas?
Great question, Marissa. So yeah, we often focus as an industry, a stormwater industry, on new development areas. And for me, I think remember Jack Mullally did some assessment a little while ago for Brisbane. It's like 1% of the total catchment area in Brisbane, or 1% of the total urban environment in Brisbane. Which means 99% is not getting any focus. It's really hard. Uh, how do you do it? How is it feasible to implement water sensitive design in old urban areas? It is difficult, but it can be done. It's really about, from my perspective, about looking at a catchment wide assessment in terms of prioritizing. So where are your high pollutant generating areas? Typically, it's areas of high imperviousness and a lot of people or traffic at least, and then working out what's physically possible in those areas. It's very easy to, as an example, to integrate gully pit baskets, recognizing I've got a conflict of interest, or devices like that, which basically
Mm.
can be put in and pulled out if need be, without any excavation works. Equally, you can look at end of line devices like wetlands, bioretention systems, etc., cartridges, where it's possible, but it is difficult. I've got a whole bunch of examples I could have shown around water sensitive urban design retrofit, but it can be very expensive. It's just I guess it's assessing whether that's appropriate bang for buck. Equally, it's not about treatment devices in its entirety. We should be looking at trying to reduce pollutant generation. And a key way of doing that, for example, is banning single-use plastics, encouraging people to not use single-use plastics, et cetera, with a whole bunch of education around that as well.
Next question from Abraham. I'm not sure how to say his last name, so sorry for that. But we have TIFA plant issues in most of our WSUD assets. Could you say about the management of TIFA in WSUD assets?
Mm. Great question. Great. Gee, we're having some doozies, aren't we? Like when I was at uni and I did a undergrad thesis on constructed wetlands for wastewater treatment, TIFA was one of the key recommended species for wetlands. And
Mm.
now it's considered a weed. And I think it's often due to the fact that it does often create or contribute to respiratory illnesses in urban areas. But yeah, it's often a really common weed because it's really hardy. It can get if it can get in, it can just basically take over a wetland or bioretention systems. Is that a good thing or a bad thing? From a purely water quality perspective, I think TIFA would be great. High biomass, high root ingress will take up a lot of pollution. So I think that's a really good thing. But equally, I know it can take over a system. If I can say anything about the management of TIFA, I'd suggest that if you want to manage it, if you want to reduce its proliferation, you need to get in early, before it takes over. Otherwise, you're looking at a fairly labor-intensive removal process. So there's ways in which you can remove it. Off the top of my head, I think you cut the sand below the water surface and it can drain out, etc. But you certainly don't want to use pesticides or herbicides. Please don't use that to build plants in WSUD and systems.
No.
I hope that answers your question, Abram.
Just noting time, we have just gone past 1:30, so people might need to start
Yep.
going, but we'll keep going with questions, Brad.
Cool.
Yeah.
And look, no harm if people need to skedaddle, get back to their day jobs. This will still be
Recorded.
available online. But we'll basically stick around until we run out of questions. So we'll try and get through these. But if you've got a burning question, feel free to email me, or we'll try and get through it into the Q&A now.
From Inna, Is Brad available to do online interstate presentations for community environmental groups?
Sure, Ina. I actually do it a fair bit. If you're not sick of my voice already, I'm happy to do it for environmental community groups for sure. At no charge. We don't charge for this sort of stuff at all.
Um, so yeah, she also just talked about community environmental groups
Mm.
also work with water authorities and councils who might be interested in your presentation. Yep. John Carlo Lastimazo, Zoa. Um, as for the urban water balance, what software or engineering tool do you use to estimate the percentage shared by different components, example, precipitation, wastewater, infiltration, etc.? And WSUD can also be applied to countries in Asia, specifically the most polluted ones.
Oh yeah, look, I guess second part of that question first. Can WSUD be applied in countries in Asia? Absolutely. Like Singapore, for example, I think is one of the leading areas for water
Mm,
sensitive urban design with their ABC Activate, Beautify, Cleanse program. I think China is really pushing hard on sponge cities. But I think for me, even just getting the basics right, just stopping the generation or proliferation of pollution, even if you don't have assets like GPTs or bioretention systems, just minimizing pollutant generation can go a long way. And then that can be achieved or at least helped with
mm.
education, a whole bunch of initiatives, et cetera, waste management infrastructure, et cetera. As for modeling software, um, look, music's an okay tool in this space. Back in the day, eWater also had Urban Developer, which was really handy. I'm not sure if they even still do that anymore, but certainly day to day at Ocean Protect, we've got a very strong focus on using music, the software from eWater. So I hope that helps, John.
Next question is from Deepak Suresh Varma. What do you feel should be next step in the evolution of the technology used in WSUD?
From my perspective, high flow bioretention systems are a no-brainer. The science is clear. They work really well. They're a low maintenance, aesthetically pleasing solution. They promote urban cooling, habitat, aesthetics. They just happen to be smaller than bioretention systems. For me, that should be a key thing. There's obviously a growing push for volume reduction as well. So I don't think the targets are necessarily appropriate, but I do believe that we do need to do more to reduce volume and frequency of flow events. So more focus on exfiltration in particular, and ideally more focus on stormwater harvesting, because it's crazy that stormwater isn't used as a more valuable resource, and we use potable water to flush our toilets and irrigate our sports fields. So I'd suggest those probably two key things. But also, finally, I feel as though we need to be more focused on the emerging contaminants. For me, the key thing that keeps me up at night, probably in terms of stormwater, is PFAS. For me, it's the number one, a key pollutant of concern that we should be more focused on. So I think there needs to be more focus around minimizing its generation and also appropriately ensuring that it's not discharged into our waterway or water body environments. So PFAS, yeah.
Next question is from Richard Boner. What materials does the filters compose of?
Look, it depends on the filters. If you're talking about Filterra, filter media, it's I can't actually tell you what it's made of. But it's basically it's made from locally available sources and carefully blended by Ocean Protect in Sydney. The membrane cartridges for jellyfish are just like membrane filter cartridges, so they're like really good at stopping pollution. It's like you can imagine like a big curtain, but folded up into very small cartridges. The storm filter media. Look, we've got 3 or 4 different types of media. Probably be a longer answer. I'm just conscious of time. So
Mm.
email me separately if you're keen to know more about the different types of media blends we have for storm filter. But long story short, we've got a lot of different types, all with different components.
Next question is from Priya Ravakumar. Any comparison for maintenance and replacement costs involved with proprietary devices compared with traditional bios?
Yeah, great question. No, but we're looking to gather information around costs around bios. But it's fundamentally so much easier to fix up a cartridge system that's been hammered with a whole bunch of pollution
Mm.
than it is a bio. For example, like, and I've seen this firsthand, like Stormwater cartridges that's been hammered with a big oil spill or what big amount of mud, just completely smothering the cartridges and the tank that they're in. Literally just come up with a sucker truck, suck the material out, replace the cartridges with new ones, and take the cartridges back and repurpose them. That's like, I don't want to belittle it. It's still a process, but it's relatively easy relative to bio and conventional bio. You're literally often having to dig the whole system up, at least replacing the top of the filter media and maybe even below that, depending on the extent of damage. And that comes at a major cost. Even if I look at, say, a GPT upstream of a wetland, if you don't have to clean out a GPT, it's a sucker truck. To clean out the same amount of pollution out of a wetland, you're draining the wetland, so pretty much killing everything in the wetland, except for maybe a few plants, and then basically doing the whole thing again. It's chalk and cheese.
Final question in the Q&A section, which might be a bit more directed towards me. But David McPherson, in Tasmania, we don't have anywhere to clean and dispose of media impacted by harmful traffic runoff, etc. Small councils do not have the budget to onboard and maintain a system pit stack with every DA, and dwellings do not have the want to clean and maintain for the design life in a small network with big quality needs. Any thoughts? So I might touch on this a bit and then give it
Sure.
to you, Brad. But
Yeah.
well, I guess for something that I've been working on is providing resources and information to councils to help them implement processes and a compliance program that can help improve and make it more efficient to have these systems maintained publicly and privately. So trying to make things as automated and distributing kind of roles and duties across the organization can help. And I think, yeah, recognizing that budget is an issue and capacity, so trying to just make it as simple and easy as possible. Um, so I think, and also just kind of working together, working as an industry together is an important thing, which is why the framework has led to the establishment of the National WSUD Compliance Network, trying to bring people together to get feedback and ideas from everyone. Because if we're all working together, we can kind of, do this stuff in a better rate and more efficient. But
Mm.
I'll leave it to you, Brad, to kind of finish off the question.
Look, I think you've done a great job answering it. But if you'd like to chat further, David, yeah, feel free to just email us or give us a call. And look, we might have to wrap up there. We've gone over time just by the extent of questions we've had. If you've got any further questions you'd like to ask us, though, feel free to reach out. But look, on behalf of Ocean Protect and everyone who's behind the scenes, thank you so much for your time today. It's really been appreciative. I hope everyone's enjoyed the session today, and I really appreciate the amount of interest everyone's shown. So again, thank you so much, and I look forward to seeing you guys at the next webinar. And enjoy the rest of your days.
Thanks, everyone.
Thanks, Daniel, for helping host as well.
All right, good job, Brad.
Thanks.